Good morning, everybody. Uh, Pawan, unmute yourself and tell me the screen is visible and audible.
Yes, sir.
Uh,
Yes, sir.
Start. Last class, we discussed about the measurement of force. Force is defined as the gravitational attraction between. Usually, the force is measured by using the calibrated device. Usually, the platform scale, electronic weighing machine, and the analytical balance are good examples for measurement of force. Next, the classification or fundamental method of measurement is classified into two types. One is direct comparison, other one is indirect comparison. So all of you know direct comparison. That is the unknown magnitude is compared with the known standard magnitude. For that good example, the vegetable chart or the provision shop, there they use a double pan weighing machine that's called the analytical balance. In the left side, they keep dead weight of 100 grams, 200 grams, and 500 grams, or 1 kg or 2 kg like that. The right side pan by adding the suppose if you want to purchase the sugar or onion or anything, so they keep on adding or removing the item in the right pan. They bring the beam to symmetry. So that is the measurement. That is direct comparison. That is comparison means the weight of the unknown magnitude means the vegetable with the known standard magnitude is a dead weight of 500 grams or 1 kg like that. This is the direct comparison. In indirect comparison, the good example is the electronic weighing machine. All of you seen in the chemical laboratory or chemical laboratory or in the jewelry shop or in the provision shop nowadays they are using electronic weighing machine. So there will be a platform. If you keep the unknown magnitude or weight on the platform which exerts the force on the strain gauges that's used in the sensors. So due to that force, there will be change in the resistance that's measured in terms of analogous signal. That analogous signal is converted into voltage signal. Again, that voltage signal is converted into digital form. That is read in the digital output in terms of grams or kgs. So that is the indirect comparison. It is defined as there will be two or more translations are present. So that's the converting the resistance into analogous signal and analogous signal into voltage signal. And voltage signal is converted into digital form that you use it for reading of the weight of the unknown magnitude. So once again, the fundamental method of force measurement is classified into two types. One is direct comparison, other one is indirect comparison. Let's come to the point, analytical balance. This is a very good example for the beam balance or symmetry of the balance. So there will be two pans positioned or placed on a triangular sharp edge. So right side and left side, there will be two triangular sharp edges. On that, they keep the span W1 and the right side, that is W2. In the center, the needle which oscillates from the zero reading right side or left side. When you bring the beam balance or you bring the symmetry of the beam, the needle reads zero. This is the measurement. This is the measurement. The principle of working of analytical balance is bring the beam to symmetrical condition. That is, the needle should read zero. Next, come to the point, very, very important. This time, you can expect this question in the examination, multiple lever system or platform scale. In Canada, in the, all of you seen in the FCMC, you have lot of vegetable mandi and also the grocery mandis and rice mandis. There they use the measurement of a large mass. Remember, the platform scale or multiple lever system is used for measurement of large masses. See, what are the things present here? Just to go through the one by one. This is the beam. Here you have a movable poise weight, WP, and here you have the graduation, where this point coincides with the graduation that indicates each each graduation represents the kg. And here the dead weights are available that you have to insert in the hook so that you can measure 25 kg, 50 kg, 100 kg like this. That is counterpoise weight, WS. You have to insert the dead weight here so that if you want to measure 23 means you to put the 10 into 2 numbers of counterpoise weight in the hook and you move the moving counterpoise to read the third division that indicates that 23 kgs. This is the beam. And the back side, there will be an adjustable counterpoise. See, before measuring anything, you have to make the instrument to read null balance. That is, null balance means that is zero reading. This beam oscillates up and down. This beam oscillates up and down when it comes to the standstill condition, that is 180 degrees. 180 degrees. That is at that point the beam is in exactly horizontal position. That indicates the weight of the unknown material on the platform. So for that reason, for this beam balance, adjust the nut provided in the counterpoise to read zero without keeping anything on the platform. And the one end of the beam is connected to a tension rod. Remember, all of you observe here. This is the tension rod T that is also connected to the beam on the triangular sharp edge. So on that point, this beam oscillates up and down. And this tension rod, again, which is connected to the platform, large platform, again, this platform is fixed at other end. And this end is connected to the tension rod. When you, I will tell you the principle of operation. This end is connected to a other end where it is hinged. On this, there will be a one more lever which is hinged at one point. Other end is placed on the large lever. Above these two, there will be a platform of size 1.75 feet by 2 feet. Imagine, or approximately 2 feet or 3 feet length and 2 feet width. So on the platform, all of you observe here. So these are on the parts present in multiple lever system or platform scale, and the size of the platform is 2 by 3 feet. That is, all of you observe here. This is the platform. This is W1, W2, and this is the W. See, where anywhere on the platform, if you keep the unknown mass, maybe 50 kgs of rice or 50 kgs of wheat or anything on the platform, that exerts the force on this lever. In turn, this lever exerts the force on the main lever. This main lever is connected to tension rod T with the help of triangular sharp edge. Due to this, the tension rod moves downward direction. Due to movement of the tension rod in downward direction, which pulls up the beam in the downward direction. Due to this, the beam moves up and down. Bring the poise weight, moving poise weight to bring the beam exactly horizontal position or 180 degree. So before that, you have to keep the dead weights provided along with the platform scale in the hook provided in the beam. That is WS. That is the weight. That is the weight. When you keep the unknown grocery or unknown mass, Shanti, Shanti Kiran, if you keep an unknown weight or unknown mass on anywhere on the platform, so you have the correct measurement. See, this W1 and W2. W1 plus W2 divided by 2, that will give you the W. That is the weight. So if you keep unknown weight anywhere on the platform, you will get the exact measurement or exact weight of the unknown magnitude. This is the principle of operation of platform scale. See, in the examination, there will be two types of questions. One, the direct question, you have to explain the multiple lever system or platform scale, this diagram along with the explanation. One more question, you have a simple derivation, that is tension T into B. So before that, all of you observe here the dimensions. Tali, class the dimensions, all of you observe here the dimensions A, B, C, D, E, F. There is no G and H. H. See, these dimensions are very, very important. All of you go through the dimensions A, B, C, D, E, F, H. These dimensions are very, very important. And next, W1, W2. Plus W1 plus W2 divided by 2, that will give you the W. And moving
Sir,
counterclockwise weight WP and the counterclockwise weight WS and the tension moving downward direction. And next come to the point, the you know the tension, you know the WS, you know the dimension, and you know the distance A. And tension T into C, W1 F by T into E plus W into H. So like this, you have to derive the equation for the measurement of unknown force by using platform scale. Then finally, all of you observe here,
Green
P
honest
in
style.
equal to H into, as I told you earlier, W1 plus W2 is nothing but W. That is that is the weight of the unknown magnitude or unknown mass. Scale multiplication ratio. This is a very, very important for accurate results. So all of you observe here, you know the dimension A to H, and you know the tension, and you know the WS, and from that you can measure the unknown mass. Next, come to the point. Say, if you come to the college later, I will show you the universal testing machine. So the name universal, that indicates nothing is impossible. Everything is possible. All types of measurements can be done by using universal testing machine. In fact, it is called UTM, universal testing machine. See, suppose if you use the universal testing machine continuously for 5 years, 10 years, or 15 years, there will be some error coming in the measure that you have to rectify, you have to avoid. So for that reason, the universal testing machine is used for loading the specimen up to 50 ton or up to 100 ton is possible, hydraulic loading. See, the problem of error in the measurement that can be avoided by using the calibration procedure. For calibration of universal testing machine, the common and simple method, simple instrument they use, that is proving ring. Fix these two ends in the two dots of the universal testing machine and load the proving ring with 1 ton, 2 ton, 3 ton, or 5 ton, or 10 ton, or 50 ton, and see that read the thread oscillates between the dimension in the micrometer right side or left side. One thing you make it clear, see, before applying the load on the proving ring, you observe that the universal testing machine should read zero. That is, bring the UTM to null balance. Then you load the ring in the direction, maybe compression or tension, and see the vibrating reed or vibrating thread along with the weight, along with the thread oscillates in the right side or left side. Where it coincides, see that that is the positive or negative dimension which is coming in the measurement. That is nothing but the error. By loading in the opposite direction or loading in the same direction, bring the read to zero, bring the read to null balance. That is the measurement. So that is the calibration. By using proving ring, calibrate the calibrate the universal testing machine or larger weighing machines. The very good example, calibration of universal testing machine. Next come to the point of very, very important, the torque measurement. The torque measurement. The second portion in fifth module is the torque measurement. First, what is the torque? The definition of the torque. What is the torque? That is nothing but the power developed by the machine or the motor or the engine, that also you can call it as mechanical power. Mechanical power, the energy developed or the power developed by the machine or the engine or any system, that is called torque. That is called. And how do you measure the torque? For that, the good measuring instrument or measuring instrument used for measuring the torque is called dynamometer. Is called dynamometer. You have lot of dynamometer in your syllabus. Only you have diagram along with the explanation. How do you measure the torque? So you can use a dynamometer. From that you can measure the torque. The torque can be defined as, or torque can be computed by measuring the force and the radius of the reaction arm. Radius radius of the reaction arm. The force F and the radius of the reaction arm, small letter R. Or even you can define like this: force into radial distance or radius of the torque arm. Both are same. The torque can be computed by defining T equal to F into R. You are all mechanical engineers. Remember in your lifetime, torque T equal to force F into radius of the reaction arm, small letter T equal to F into R. T equal to F into R. This is the torque equation. You have to remember in your lifetime, torque can be defined as the force into radial distance, like this. That is force into radius of the reaction arm. There will be three types of dynamometers are available for the measurement of, that is absorption dynamometer, driving dynamometer, and transmission dynamometer. Next, come to the point. What is absorption dynamometer and what is driving dynamometer? See, the name itself indicates absorption, that absorbs the energy developed by the machine or developed by the engine or developed by the motor. Absorption, whichever the mechanical energy coming from the machine, that is absorbed by the dynamometer and shows the result in terms of kg meter, not it is per, it is kg meter. Absorption of mechanical energy, that is kg meter. Name itself indicates which absorbs the energy. Next, come to the point, the driving dynamometer. Driving means the energy developed by the engine, developed by the machine, which is transferred to the another system to measure the torque. That is called driving the another motor or another system, that is driving dynamometer. For this, good example is pump and compressor. In pump, what will happen? There will be a motor which is connected to the creates the vacuum and sucks the or suction takes place and the water is pumped to very high, so larger height. So driving dynamometer, the good example is compressor and the pump. The driving means that is which drives the another system. From that you can measure the torque, the energy, mechanical power developed by the engine. Next come to the point, that is the transmission dynamometer. Next come to the point, the absorption or mechanical dynamometer. In turn, it is also called as Prony brake. Prony brake. Please, all of you, write down the question. What is torque? What is torque? All of you, please write down the question. What is torque? Next, list the torque measuring torque measuring operators. List the torque measuring operators. That is absorption dynamometer, driving dynamometer, and transmission dynamometer. That is, transmission means from one place to the other place, they transfer the energy, mechanical power from one place to the other place. In the other place, if you measure the torque of the engine, torque of the motor or the machine, that is called transmission. That is transferring the mechanical energy from one place to the other place. Next, come to the point, the method of measurement of torque by using absorption method, that is the mechanical dynamometer which is available, that is called Prony brake. We already discussed about the platform scale. See, all of you observe here, this is the platform scale, this is the platform. On that, the force is exerted on the platform by the mechanical energy coming from the machine or from the motor or from the engine, which exerts the force on the platform. And this is the arrow mark shows the driving of the shaft along with the pulley of the dynamometer. This is the beam. Below that there will be a wooden ellets. Wooden ellets. For this good example is all of you seen the brake shoe and the brake pad in the two-wheeler or in the four-wheeler. What will happen? Which presses the shaft and bring the pulley or engine to standstill condition by pressing the shaft, bringing the shaft to 0 rpm, which is running at 1200 rpm. Bring the shaft to the zero speed, that is by pressing with the wooden ellets, just like a wooden ellet. In turn, we can call it as the brake shoe along with the brake pad, which presses the shaft to come to the standstill condition, stop condition, and stops the shaft. Due to that, there will be a force coming from the running of the shaft that exerts the force on the platform that you can measure by using in terms of kg force. Kg force. Usually, the torque is measured in terms of kg meter or kg centimeter or kg meter. This is the simple the braking system used in two-wheeler or four-wheeler, and also in some of the machine tools they use the braking system. In turn it is called as mechanical dynamometer. In that you press the shaft to slow down the speed of the engine. That is the force exerted on the platform that can be measured in the platform scale, that is the torque in terms of kg meter. And all of you observe here, this is the force perpendicular distance, and the distance from the center of the shaft to this platform scale, this is the radius. This is the radius. That is T equal to force F and distance R. So that will give you the torque. This is the principle of operation of Prony brake. This is also called as mechanical dynamometer. All of you observe here. All of you understand. This is a very important. You may have this question in the interview: which type of dynamometer used for the measurement of torque developed by the engine? That may be diesel engine or petrol engine or motor. You can use the absorption technique or the mechanical power developed by the engine or developed by the machine or developed by the motor, that can be measured by using the technique absorption technique, that is absorbs the energy by pressing the motor by using wooden ellets or brake pad. From that you can press the shaft to slow down its speed. That is the beam is connected to the shaft is connected to the beam, which exerts the force on the platform scale, which in turn exerts the force on the platform scale. We can measure the torque of the engine. This is the absorption type of dynamometer or mechanical dynamometer or Prony brake. See, all of you, please write down the question. Write down the question. The examination point of view. This is very important. This time you have this question in the examination. This time you have this question in the examination. You can expect 100% guarantee. That is, explain briefly. Before that, right now. What is torque? What is torque? What is torque? Okay, question mark. Explain briefly. Explain briefly with need sketch. With need sketch. Absorption dynamometer. Absorption dynamometer or mechanical dynamometer. Mechanical dynamometer or Prony brake. Prony brake. All of you observe here. Prony brake. Prony. Prony brake. Put a question mark. Put a question mark. List the applications and limitations. List the applications and limitations. Now I stop at this stage and I will continue in the next class. Now, please all of you enter your name and USN. Prajwal Chaudhary, please answer roll call. Prajwal Chaudhary. All of you, please unmute yourself. Answer roll call. Prajwal Chaudhary. Yashwant.
Sir. Present, sir.
Yes, sir.
Varsha. Vinayak. Vinayak N.
Yes, sir.
Rajat. Rajat.
Yes, sir.
Pawan H.
Present, sir.
Vedas. Vedas.
Present, sir.
Vinayak JH.
Present, sir.
Prithvi Mahesh. Prithvi M.
Present, sir. Present, sir.
Mehtab. Yashwant.
Yes, sir.
Pritam D.
Present, sir.
Sanjay K.
Present, sir.
Nitin LM. Nitin LM. Pratham P. Yashwant. Shashank HS.
Present, sir.
Pawan T.
Yes, sir.
Renil.
Yes, sir.
Yashwant.
Yes, sir.
Rahul MP. Anybody else? Please pronounce your name.
Rahul MP, sir.
Huh?
Rahul
Pronounce
MP.
your name.
Rahul MP.
Okay. You are joined with Varsha's mobile. Okay, no problem. Okay, now I stop at this stage and I will continue in the next class.